So this question is pretty self-explanatory. You pretty much just have to add these together. People that got it wrong because they made a careless error in terms of their adding. Just in terms of people that are interested in strategies to help them go faster, the only thing that I would suggest is that you break the numbers down into their place value. So for example, you could take the 1 plus the 2 plus the 3 plus the 4 plus the 5. And very quickly you should see that that's really just 5 plus 5 plus 5, or 15. So you've got 15 ones. Then you can look at the tens place. You've got 3 and 4 and 5 and 6 and 7. And again, very quickly you see, if you look at the numbers closely, you see 10, 10, and 5. So very quickly you should be able to see that that's 25, but that's 25 tens, so that's really 250. And then again, if you kept that going, you could look at the hundreds place. You've got 5, 6, 7, 8, 9. Again, there is a little bit of a pattern there, 14, 14, and 7. So you could do 14, 14, 7 fairly quickly in your head and get 35. But again, realizing that that's the hundreds place and getting 3,500. And then really you just have to add those three numbers together. It's just a little bit faster. It's not something that you have to do, but for people that are looking, sometimes with contests, it's not so much the math that's hard, it's the time, right? You take too long on a question. So there's a really quick way to add those numbers quite quickly in your head. Let's look at the second question. So probably, I would say the best way to approach the second question is just to list the first 40 odd counting numbers. Now, don't get thrown off by the word counting numbers. It just is a normal number, 1, 2, 3, 4, 5. Those are all counting numbers. Odd, you should know that those are numbers that end in 1, 3, 5, 7, 9. So really, you could just list 1, 3, 5, 7, 9, etc. And if we listed all of the first 40 numbers, we're eventually going to go all the way to 79. I'm not going to write them all out, but if we list all those, we're going to see that we get all the way to 79. So really, I didn't even need to list them out, because if I think this through, how many times do I see 3? I see 3 there, I'll see it there, I will see it there. And then this is where you have to be careful. You will actually see it there a few times. And then you'll see your 43, your 53, your 63, your 73. Okay? So again, I started off by listing them, but then I quickly realized I don't actually have to write every single number out. I just have to know what my beginning number and my end number is, and then I can just write down all the ones with 3s in them, and I literally just have to count 1, 2, 3, 4. This one's tricky. 5, 6, 7, 8, 9, 10, 11, 12, 13, and that's your answer. So this one stuns some of you and not all of you. One thing to keep in mind is your paper for your contest is rectangular, and so sometimes it's hard to think abstractly with shapes, but sometimes if you have the shape in front of you, it's a lot easier. So you could kind of think like of your paper that was your contest paper as being 8 by 12, and then think, okay, my first fold will be here. And so when I fold that, it's still going to be 8 this way, but it's no longer going to be 12, it's going to be 6 this way. Then I need to fold it the other way. Oh, sorry, it said first vertically and then horizontally. So you should have done it the other way around, but you end up with the same, actually here. I'll fix it by just, if I make that one 12, no, it doesn't matter. Just think of it in the same way. It doesn't actually matter what order you fold them in. So I did horizontal and then vertically because I didn't read it carefully, but it makes no difference. So now if I fold it this way, I'm going to get still 6 this way, but this way is now going to be 4. So I'm going to end up with a rectangle that's 4 by 6. The question is, what's the area of the new one? Area is base times height, and I get 24 centimeters squared. And that's all I needed to do. So you literally just have to fold it once one way and once the other way and see what shape you're left with. As I said, I accidentally did it the wrong way. You end up with the same answer. So a lot of you found this one quite challenging. It's kind of based on a magic square, sort of. So if you're interested in practicing these kinds of things, look up magic squares or magic shapes. There's some that aren't just squares. But basically what you had to realize is we wanted the least possible product. And remember, product means the answer to a multiplication question of the numbers in the gray row. So if I think of the numbers from 1 to 7, my smallest numbers are 1, 2, and 3. So right away, I'm actually going to try putting 1, 2, and 3 right in that row, because there's nothing smaller than that, and I'm going to see if I can get that to work. Then what it talked about was making sure that everything in the left, everything in the right, and everything in each diagonal equaled the same sum, which means to add them. Okay, so what I want to think about then, I'm just going to take those away, is could I start to be putting the remaining numbers? So remember, I'm left with 4, 5, 6, 7. So where could I be putting 4, 5, 6, 7 so that happens? And then I really can just start playing with numbers. So for example, I don't want to put all the high numbers together or all the low numbers together. I want to mix them up a bit. And I probably want to pair the highest number with the 1, because that will help me. So I might put the 7 here. So I pair the highest number with the 1. And then I want to maybe put the next highest on this side, because I don't want to put both highest numbers on one side. And then I can see, well, this adds up to 9. This adds up to 8. So what do I need to put here and here? So I would have to put the 5 there and the 4 there, and then I'm going to test it out. What's 5 plus 1 plus 7? And I get 13. What's 4 plus 3 plus 6? I get 13. Now let's go diagonally. What's 6 plus 2 plus 5? I get 13. And what's 7 plus 2 plus 4? I get 13. So again, the strategy here was I actually started with the smallest thing. I kind of lucked out. 1, 2, and 3 worked. But if that didn't work, I would try something else. And then I pair the smallest number with the biggest number, and I kind of go backwards from there. So then the question wasn't just what are the numbers, the question was what is the product of the numbers. So then I just have to figure that out, and I get 6, and that's my answer. So I would say that this one was definitely a stumper for many of you. Remember that every B has to equal the same thing, every T has to equal the same thing, every E, etc., etc. So the way that I would approach this question, you want to get the smallest sum possible. The way to do that is for the things in your highest place value to be the smallest number you can possibly make. It tells you right here, that symbol means does not equal. So it tells you that B cannot be 0, but it can be anything else. So what's the next smallest thing? That means the next smallest thing is 1, and I would actually put that there. Then I go to my next place over, because again, if I'm creating the smallest sum, I want to work from my biggest place value. I want my biggest place value to be the smallest numbers, and my biggest numbers to be on the ones. So now I start putting in the next smallest numbers. And notice how I've got quite a few E's, not that it really matters, but the next smallest number is actually 0 because I'm allowed to use 0 here. So now, everywhere I filled in the B, E, T, T, everywhere I see, shoot, I've messed that one up, but you get the hang of it. Everywhere I see an E, I'm going to put that 0. Okay. Then for my I, what's my next smallest number? That's a 2. And there aren't any other I's. And then my A, I'm going to put my next smallest, which is a 3, and there aren't any other A's, and then my next smallest will be there. Which leaves me with, for my T, my next smallest number is a 5, and there's lots of those. And then finally, the next smallest number is my R. And that, all of those numbers, when I add them, will give me the smallest answer. Why? because I put the smallest things in the highest place value and I worked my way down to the lowest place value. When I add these all together, I end up getting 512,024, and that is the answer. So again, it looks really complicated at first, but if you use the right strategy, it's actually not too bad. And that's part of being involved in this contest, is not whether you get it right or wrong, it's learning these strategies so the next time you get a question like this, you'll have a better way to approach it. If you have any questions, just come and talk to me and we can go over any of these problems.